You ever look at a massive bridge, a skyscraper, or even just your car and wonder how all those pieces of metal get put together so perfectly? Well, the secret isn't just a steady hand. It's a hidden language, a kind of universal code that tells a welder exactly what to do. And today, we're going to decode that language.
So think about this for a second. You're the engineer. You have to tell someone, maybe on the other side of the country, precisely how to fuse two heavy pieces of steel. We're talking shape, size, location, everything. How in the world do you cram all that 3D information onto a flat piece of paper without anything getting lost in translation? You do it with a system just like this, from the American Welding Society. Now, this isn't just some boring chart. No way. This is an incredibly elegant solution. It's a visual language where every single line, every shape, has a very specific, undeniable meaning. It's basically the Rosetta Stone for fabricators, letting anyone, anywhere, build our world the right way. All right, to learn this language, we've got to start with a basic anatomy. Just like any sentence is built from words, every welding instruction you'll ever see is built from just a few core parts. And get this, it all boils down to just two things: a horizontal line, which we call the reference line, and an arrow that points to the exact joint and the blueprint. That's it. Seriously, everything else we're about to learn is built on this super simple foundation. Now, this is where the real genius of the system kicks in. That reference line acts like a divider. Any symbol or number placed below the line applies to the side of the joint that the arrow is pointing to. We call that the arrow side. Anything placed above the line applies to the other side of the joint. It's such a simple rule, but it solves a huge communication problem instantly. And this shows you exactly what we're talking about. Look at the left, you see the arrow points right to the arrow side of joint. Super straightforward. But check out the T-joint on the right. You could weld the near side or the far side, right? Well, by putting the symbol either below or above that reference line, the blueprint tells you arrow side or other side with absolute clarity. No guesswork. Okay, so now that we get the placement rule, the where, we can finally learn the what. We're about to get into the alphabet of welding, the basic shapes that tell you exactly what kind of weld to make. And here's the best part. This language is unbelievably intuitive. You don't have to memorize a bunch of random shapes. As you're about to see, the symbol for the weld very often looks just like a cross-section of the actual weld.
Let's take the most common weld in the world, the fillet weld. It's used to join two pieces at an angle, like inside a corner. And what shape does that weld make? A triangle. So what's its symbol? A simple triangle. See, it just makes sense.
Let's do another one. For what's called a V-groove weld, you actually grind the edges of the metal plates into a V shape before you fill it in. So what do you think the symbol is? Yup, it's literally a V. The symbol shows you exactly how to prep the metal. Once you see it, you can't unsee it. Okay, so we've got our location and our basic shapes. You could say we have the nouns and verbs of our new language. Now we need the grammar, the stuff that adds all the critical details. I know, this diagram looks a little intense at first glance, but just think of it like a template or a map. It shows us where every single piece of information goes. From how big the weld is, to how long it is, to how to finish it, everything has its own little spot. Let's break it down. We're just going to focus on the three big ones today. To the left of the weld symbol, you put the size, labeled S. Super important. To the right, you've got the length, L. And right after that, if the weld is stitched instead of one continuous line, you put the pitch, P, which is just the spacing from the center of one weld to the center of the next. Size, length, pitch, left and right. That's the core of it. And here's the real point. With just these few things, the arrow and line, a simple shape, and a couple of numbers, an engineer can communicate what they need with like 99% clarity. And that precision is what prevents mistakes that could lead to catastrophic failures. This isn't just about being efficient, it's about being safe. All right, this is it, the moment we've been working towards. We've learned the anatomy, we've got the alphabet, we've touched on the grammar. Now let's put it all together and actually read a full sentence in the language of welding. So we're looking at that master diagram again, but this time it's not a template. This is a command. Let's decode this thing together, piece by piece, and turn it into a simple, plain English instruction. Okay, let's read it off. First, that triangle tells us we need a fillet weld. Got it. It's sitting above the reference line, so that weld needs to go on the other side of the joint. The number to the left,
S, that's our size. The numbers to the right, L and P, tell us the length and the pitch. And see that little curved line on top of the triangle? That's just an extra instruction telling the welder to finish the weld with a slightly rounded, convex surface.
And there you have it. From one tiny little symbol on a massive blueprint, you get a super detailed 6-part command: the type, the location, the size, the length, the spacing, and the finish. It leaves absolutely zero room for error. That is the incredible power of this system. It's a whole paragraph of instructions squished into one simple graphic. So, the next time you walk by a construction site, you'll know. Those blueprints are covered in this secret code, this language that turns lines on a page into the world that we live in. Which kind of makes you wonder, doesn't it? What other hidden languages, what other brilliant symbols are all around us, quietly holding our world together?